Bless you. Good timing. That's great. That's like instead of action. Okay. Good morning, class. Today we're going to be doing geometric means. I'm going to explain what that is in just a second. All right. It's the fourth quarter. It's the day after the 2-year anniversary, so I'm looking forward to a lot of enthusiasm, a lot of energy. So let me hear you. Yay, math! Nice. That was a good one. All right. Cool. Cool. I can tell you're ready. Okay, the geometric mean goes as follows. The geometric mean goes as follows. Please write the following numbers. Artiste, draw the following numbers. Let's go with, okay. So we have 1, we have a blank, we have a 4. Okay? So now, can you give me a number? Can you give me a number so that the ratio of 1 to this number is the same ratio as this number is to 4? Okay, your hand was up first. Okay, so we're hearing 2. Let's put 2 in and take a look. Is 1 to 2 the same as 2 to 4? Yes. Yes. All right. I think we'd even draw that. 1. I'll even use box technique here. Box technique is like a Tybo. Okay. So yes, 1 to 2 is the same as 2 to 4. I'll give you another one now. Here we go. 2 is to what number? The ratio of 2 to what number is the same ratio as that number to 18. Okay. I'm liking the hands, so I want to think about it. Think about it for a second. 2 to what number is the same ratio as what number to 18? Yes, sir?
6.
6. Okay. How'd you get 6?
I tried to figure out a number that I was thinking of even numbers.
Even numbers. So you kind of worked it out in your mind. Okay. So what if you didn't know how to do it in your mind? Is there a formula that you can do? Yeah, there is a formula. It's actually on the board. What do you think?
Yeah, can't you just do like 2 over 6 equals to 6 over 6?
Right, but what if I didn't know 6? So 2 over what?
2 over x.
2 over x, right. So 2 over x equals x over 18. This is x, in other words. So what we're trying to do is find the geometric mean between 2 and 18. Not the normal mean, right? The normal mean is the average, right? You've done that before many times. What's the average or the normal mean of 2 and 18? 10, very good, it's 10, right? Add them up and divide by 2. So 2 plus 18 is 20, divided by 2 is 10, right? So 10 is actually right in the middle of 2 and 18, that's correct. But the geometric mean is something different. It involves ratios, okay? So now you know how to do this. What's the 2-word solutional way to solve this? Yeah? Cross multiply, and you get what equals what?
You get x squared equals 36.
X squared equals 36. What do you do to both sides? Say
by x. I mean,
it's okay. It's okay. Yeah.
I forgot.
What's it called? Yeah? Square root. You guys can speak up. We're in the library. Okay. X equals 6. So there it is. So that's the geometric mean. That's what it's called. Okay? Now, here's what's interesting. And here's what Mr. Rabbi Adut is going to change. I actually do my own thing when it comes to problems like this. With problems like this, when you're solving for x and y, there's all kinds of geometric means that you can do. There's rules. The relationship of 4 to this line is the same as this line is to 2, for example. Little relationships here and there that you'd actually have to kind of look at and figure out. But what I say is, you don't need to necessarily know geometric means, but you just need to know that these are similar triangles, all right? And so we're going to base this lesson on similar triangles. Okay, so how many triangles do you see here?
3.
Yeah?
3.
3 triangles, okay? So can we call these triangles the small, the medium, and the large?
Yeah.
Okay, so let's call them the small, medium, and large. This here for a second. So small, medium, and large. And now, this one's the small one, right? Right here. This one's the medium, and this one here is the big one. Could even mark them in color. Small, I'm going to draw in blue. Make it pretty, pretty. Medium, I'm drawing in red. Make it prettios, minios. Okay?
The big one.
The big one.
That's the oops! I wanted to make it so pretty.
We'll just leave.
Yeah, just leave the big one in red? Okay.
Yeah.
Okay, so then we can go like that. We can go small is blue, medium is black. Okay, and large is red.
Now that's American spirit.
Yeah. Okay. And so, if these are similar triangles, wouldn't it help us to draw them side by side? And then we can make comparisons. Okay? So, I'm going to draw the small one now. It goes like this. Here's the small triangle. Now, talking about the small triangle, we need to look at it closely and figure out where is the hypotenuse. Which side is the hypotenuse? Yeah, do you know?
Y.
Why? How do you know it's Y?
It's opposite. It's diagonal the right angle.
Right angle, correct. It's opposite the right angle. So, let's put Y here.
Wait, so you flipped the
Yes.
small?
Yeah, right. We oriented it in a way so that we can see it. And it also, it's aligned with the big one too, so we're picking one that works for us, okay? That sort of like spatial orientation is at the heart of geometry as a class, all right? Be able to manipulate shapes on your paper. All right, so we have the hypotenuse. And do you agree we have two legs, one of them short and one of them long, okay? What is the short leg from your best judgment here? Which one's the short leg? Yes, 2. And so where should I put the 2? Here or on the bottom? The bottom, 2 is coming. Okay, and what is the long leg in this small triangle?
2.
The long leg in this small triangle
Oh, we don't.
is here. We don't know it, correct. So we're done with the small triangle. Medium triangle coming up, oriented the same way. Okay, facing the same way. We have right angle, hypotenuse, long leg, short leg. Okay, here we go. Volunteer for medium triangle. Anything, any side. Yes, give me one side, please.
The hypotenuse is X.
The hypotenuse is X. If this is a 90-degree angle, is this one too? Correct. So, like your neighbor just said, opposite the right angle is the hypotenuse, so indeed that's X. We put an X here. What looks like the short side? Is it 4 or is it the blank? Yeah, any questions about that? That this is the blank side, it's the short side, right? So short we don't know. Long leg would be what? 4, good. Okay, moving on to Mr. Big Pants. Okay, take a minute and see if you can fill out every side of this one. It's actually pretty easy because they're given to you, you know. All right, what do you have?
Hypotenuse is 6.
Hypotenuse is 6, yeah, that's the hard part.
Left side is Y, long side is X.
Okay, now look what happened. Now we have 3 triangles in which we can make ratios to solve for X and Y, okay? And now we need to look at them and say, okay, I need to pick 2 of them, make a ratio, and solve for either X or Y. So let's solve for X first. Am I looking at this triangle to solve for X? No. Am I looking for this one possibly? Am I looking at this one possibly? Yes. Okay. Let's make a ratio between these 2 triangles. Good, you've been great. Let's look at some new peeps. Some new peeps. Yes, sir. Yeah.
6 over X
6 over X. equals,
No, not, is it?
over this x?
Yeah,
That's fine. 6 over this x, good.
yeah, equals x over 4.
X over 4, right. Hypotenuse over hypotenuse equals long leg over long leg. That's right, write it. 6 over x equals x over 4. And doesn't this look like the formula for geometric mean, in which the two missing pieces that we're looking for are diagonal from each other, just like we did before? So with this method, I believe, I think it's best to do it this way. The book has you memorize formulas. I believe drawing them in this way reduces your need to memorize formulas, and instead just makes it a logical thing. You're not memorizing, it becomes a logical thing now. And then we solve. Okay, so x squared equals?
24.
Don't forget about simplifying radicals. Radicals with a Z at the end, because that's how you guys talk. Radicals, Mr. Idiot. Okay, so, it's all in love. Who remembers what to do? Yeah? Yes?
Don't you put it into square root?
Yes, 2 square roots. So you break them into 2 numbers that multiply to 24, and one of those numbers should be a perfect square. That's right. So give me 2 numbers that multiply to 24, in which one of them is a perfect square. Yes?
6 and 4.
6 and 4 is right. 6 times 4. Okay, and so we can break it up. 6, 4. So can we simplify the square root of 6? No. What's the square root of 4? 2. So this answer becomes 2 rad 6, or 2 root 6, or 2 times the square root of 6. Very good. X done. Okay. Questions so far? Okay, we're going to do y, and then we're going to do one more triangle, and we're done for that. All right, so let's do y. Why not? So, are we possibly going to use this triangle? Yes. Are we possibly going to use this triangle? No, not for now. Are we possibly going to use this one? Yes. Now, a backup plan, there's some backup plans. If you're really confused, you could always put x here, you know? You could always put x here, and you could put x here. What if I put x here? Could I solve for y now?
Yeah.
Using what theorem? Pythagorean theorem, that's right. If I put x here, a squared plus b squared equals c squared. So I could do y squared plus this, 2 root 6 squared equals 6 squared, which is 36, okay? But for now, let's do geometric means. All right, hook it up, as my cousins said when they came off the boat. Hook it up! Yeah, please.
You do 6 over y equals y over 2.
Very good. So now, your neighbor actually did 6 over this hypotenuse y. What we can do also, which is the same thing, is 6 over y. So hypotenuse over short equals y over 2, just like you said. And that's just as fine, right? Just getting the variety. 6, let's make a little thing. 6 over y equals y over 2. Again, look familiar. Geometric mean between 6 and 2. Geometric mean, the y's are diagonal from each other. All right, so we got y squared equals 12. Da, 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 da. Okay, is 12 a perfect square? What?
No.
No, it's not. Okay, so what times what equals 12, and which one is a perfect square? Yes?
4, 3.
4 and 3.
And then it'd be 2 that
Right, so this intermediate step is not necessary once you know what you're doing. So this becomes, the square root of 4 is 2. That's 2. And then, so that's gone, and then the 2 stays inside like so. All right, so square root of 4 became 2.
But yeah, that would be 3. Not
3, yeah, thank you. Good job. That's good, looking out. That's good.
How do you get rid of the 4?
The square root of 4 is what?
2.
There it is. Okay. And then once you get going, even this step becomes unnecessary. Okay? You guys get ready for that when you go to Algebra 2 next year. You could even go here. You can say, okay, hiding inside 24 is 6 times 4. 4 comes out and becomes 2, and the 6 stayed inside. All right? Same with this here. Any questions? Okay. Maybe do the thing where I speed up the racing. It's funny. Let's go ahead and draw 3 triangles. Let's decide on a direction together so that we're all looking at the same thing. What direction looks best for you guys? Do you want to draw them all 3 like the big one? All 3 like the medium one? Or perhaps all 3 like the small one? Again, you see the 3 triangles? Big one, medium, and small. I have a preference, so see what you guys think. Do you want to draw them all like the big one?
Yeah.
Want to draw them all like the big one? Okay. It's not really,
Not the small one.
it's not usually done that way. I mean, forget usually. There is no usually anymore. You could do them all that way. The problem is, generally in our minds, we think in terms of vertical and horizontal. We're used to reading that way. So most of the times, especially when you're learning about right triangles, you try to make them like as much like this as possible, or like this. So I was thinking make them all look like that. So that way at least it's like we're used to seeing it. Okay? So let's try to do it without color now and see if you understand. So here is the small one, like so. Okay. Hypotenuse. Long leg, short leg. Hypotenuse is what? Y. Long leg is what? X. Short leg is what? 3. Okay, so that's the easiest one. Now let's do medium, or grande, as you guys call it. Okay? And then venti. Venti comes from the Italian word 20. Right, 20 ounce. Okay, medium triangle. What is the hypotenuse of the medium triangle? Unknown. Look at it closely. Medium triangle is here, this guy. Opposite the right angle, here, unknown. Okay. What is the long leg of the medium triangle? Yes, heard it? 8, that's right. What is the short leg? X. Very good. Big one. There it is. Okay. What is the short leg here in the bottom?
Why?
Y. Any questions? Feel free, please. This is your time, you know? I want you to get it. And that's very impressive, you guys. Remember the first picture on the board you were having, it was like, oh my god, what do I do? In only 20 minutes. It's very good. You really saturated it well. Okay, so here's Y. What is the, what's the long leg? Unknown, right? The long leg is here. And what is the hypotenuse? 11. Okay. No, so let's make a ratio involving just x. Ratio involving just x. Okay, I see it. Are we going to use this triangle?
Yeah.
We're going to use this triangle?
Yeah.
We're going to use this triangle? No. So this one's out for now. And let's make a equation involving x. Please, yeah.
8 over x equals x over 3.
8 over x over 3. Or 8 over x over 3, right? Or x over 8, 3 over x, it's all the same. It's all the same. So let's do what you said. 8 over x equals x over 3. So on your tests and quizzes and things like that, if you see something like this, most likely you're in the right direction. See what I mean? With the x's opposite each other? Okay. If you saw x's across from each other, that's probably wrong. Okay, here we go. X squared equals 24. Square root both sides. We did this one before. So what's the answer?
X equals 2 to the square root of 6.
All right, 2 root 6 is right.
Thank you.
Bless. All right, one more. One more. Shit, I gotta look from the window. Okay, so y. This one? This one, no. This one, yes. All right, so one more equation. Got it? You got it? Yes.
11 over y. No, that.
Okay,
Oh,
11
yeah,
over y.
equals 7.
That's right. Cool. 11 over y equals y over 3. Okay. Y squared equals 33. Okay. Square root both sides.
You can't square root.
Is square root of 33 a perfect square? Can we make two numbers that multiply to 33 in which one is a perfect square? No. So what do? We leave it. Right on. Quick question, is 33 prime?
Yes. Well, no.
No, it's not prime.
11 times 3.
Right, 11 times 3. That's right. But it's not a perfect square, nor can it break. Okay, any questions on that? Geometric mean. I think you guys took to that really well. Okay? Okay. So thank you for your enthusiasm. My ears are still ringing from before. That was really loud. Thanks. I'm going to go see your doctor now. Okay, bye. 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 Is it off?
Not yet.
Okay, bye.